A machine produces bolts with a mean diameter of 0.25 inches and a standard deviation of 0.02 inches. What is the probability that a bolt will be produced with a diameter greater than 0.3 inches, assuming diameters are approximated diameters are approximated by the normal curve? So we're saying we have a normal distribution here. That's what saying approximated by the normal curve is. We have a mean of 0.25 and a standard deviation of 0.02. So that means if I was to step over once, I'd be at 0.27. If I was to step over twice, I'd be at 0.29. It looks like to be greater than 0.3, we're going to have to step over 2.5 times. So I can actually see that this is z equals 2.5, but I could have also figured that if I care about what my z-score is. I don't really need it here, but I could have figured that out by doing 0.3 minus 0.25 over 0.02. So we do 0.3 minus 0.25 divided by 0.02, which gives us 2.5. So you can see that is the z-score here. We're 2.5 standard deviations above the mean. We have a z-score of 2.5. Again, that's not really necessary if we're plugging this stuff into the calculator. We have a cutoff score, and we're trying to find what is the probability that we're above this, that we're greater than this. So we have a cutoff score. We're trying to find a probability, which means we want to use normal CDF. With normal CDF, I need, of course, my mean and my standard deviation. Those are given to me. I also need my lower and my upper. Well, my upper goes off to infinity. It goes off forever in that direction. So my lower bound is going to be 0.3. My upper bound is going to be 10 to the 99th. My mean is 0.25, and my standard deviation is 0.02. So I type that stuff into the calculator, and I can get 0.0062. It's not very likely that a bolt is going to be larger than 0.3 inches. It would be kind of bad if it was that big.